How you doing? My name is DCorcione. I'm a sophomore in the mechanical engineering department, and I'm from Boston. Alright, I'm going to give you a tutorial on how to use EES, which is the Engineering Equation Solver program. In the mechanical field, the software can come in very handy for preparing thermodynamic equations and scenarios. It is a software that allows you to calculate predictions for thermodynamic processes. We will use an example regarding tire pressure. Pressure inside of a tire is very dependent on the temperature of the air. So first off, if you don't have EES, you can download it at here, mhhe.com, which is McGraw-Hill. Very easy to download. Some thermodynamics textbooks come with the software. I already have it downloaded, so I'll just open that up. And here, this is the equations window, where you'll do all your inputting your equations. In our scenario, we'll start with temperature. We use T1 equals 25, and then to put our units, we put them in brackets, and we'll be using Celsius, so capital C, close the brackets. A new line for our second property, which will be, we'll label it PG, which will be the pressure inside the tire, equals 210. And our units is kilopascals, so kilopascals. Close the brackets, new line. The volume inside will be V1 equals 0.025, and our units for volume are meters cubed. Now to put it as cubed, we use the caret symbol, which is shift and then press 6 on the keypad, and then 3, close the brackets. The resulting temperature we'll label T2 equals 50, and then brackets, Celsius. We assume that the atmospheric pressure is 100 kilopascals, so we're at sea level. We'll type that in as P ATM, meaning atmospheric, and then 100 kilopascals, new line. So the equation for our first pressure will be P1 equals PG plus PATM. This is very similar to Excel and other spreadsheet programs. The computer will know what PG is, what PATM is, because we already identified those two, and then it will solve it, and it will give us a value for P1. To calculate P2, we use pressure 1 multiplied by temperature 1 divided by temperature 2. We type that as follows. P1 multiplied, we're using shift 8 to make the multiplied sign. T1. Then we want to convert Celsius into Kelvin, so we'll add 273 to that. Close that parentheses. And we divide T2 plus 273. Close that, and then enter. Now what we ultimately want to find is volume 2. Once the temperature is increased, we want to figure out what the final volume will be. How much pressure and volume is inside the tire. To use these equations, or to access these equations, we can click Options, Function Info, and then here we have a few different options we can select. We're going to be using fluid properties. On the right side, you can select which fluid you're going to be using. They have tons and tons of different fluids. We're going to be using air. On the left, we select the equation that we want. And in our case, it's volume. And then our two variables that we're going to use in our volume equation will be temperature and pressure. Right here shows the example of the equation. And what we're going to do is we're going to retype this, turn this into V2, volume of air. T in our instance will be T2, and P, pressure, will be pressure 2. Select paste, and there the program has inserted our equation. Now to calculate it, we can hit calculate, or the calculator icon right here on the toolbar. Click calculate, and here are our calculations. We'll minimize this so it fits all in our window, and there it is. All right, and the potential problem it noticed was 273 when we added, in order to find P2, it noticed 273 was dimensionless. We didn't add any units to it, so it's letting us know that there's no units being added to a term with units. So it just got a little confused there. But our equation worked out well. One of the great things about this software, knowing this information can help prevent burst tires in very high temperatures. If we know how much is supposed to be in the tire at normal conditions, then when conditions change, we know whether to add or remove air from the tires to avoid complications. This is very useful in professional racing. I know racetracks get very, very warm, and there's a high potential for tires exploding, and there could be damage to the car, damage to the track, damage to the riders, damage to the fans. So, in order to prevent that, this software can help pit crews and owners and manufacturers make a product in an environment that's safe for everybody. I hope you enjoyed the tutorial. If you have any questions, feel free to leave a comment, and I'll get back to you as soon as possible. Thank you.